Hello everyone. This talk is about blockchain-based OT monitoring solution, namely BBOTMS. Today I'm going to talk about operational technology OT and its cybersecurity, security mechanisms like OT monitoring solution, what are the challenges in deployment of OT monitoring solution, and how blockchain technology can solve the problem of OT monitoring solution deployment. So who are we? I am Asif Hameed Khan, and my area of expertise includes operational technology, cybersecurity, cyber threat intelligence, and digital forensics and incident response. I also run my own platform on LinkedIn and Twitter with the name OTISP, OT Threat Information Sharing Platform. So you can follow us for more OT ICS related news and updates. Today, I have my friend Gagan Singh Jattana with me. His interest lies in IoT pen testing, hardware security, and firmware analysis. Introduction to operational technology. The endpoints in IT environment is desktops, servers, laptops, etc. But the endpoints in OT environment is field devices. Just like IT endpoints, it collects inputs, processes it, and gives output. These OT field devices like sensors, actuators, etc. collects real-time data and send it to controllers like PLC RTU, which can be thought of as industrial CPU designed for a specific purpose. These controllers are programmed to get specific output based on inputs provided by the field devices. So we can say it's a control loop wherein we collect data and send it to the controller for output. Take an example of air conditioner. Temperature sensor gives input to the controller and based on temperature defined, it takes decision whether to on the AC or switch off the AC. In order to manage and view the controllers, we have human machine interface, namely HMI consoles, where you can configure and govern controllers. Suppose we are having manufacturing plant of 3 floors and in all floors HMI is installed. When we manage and govern multiple HMIs within the plant environment of large continuous processing facility at one place, we call it a DCS, distributed control systems. If we manage and control same operations remotely rather than on-site, we call it SCADA, supervisory control and data acquisition. These hardware and software working together to achieve industrial objectives is known as Industrial Control System, ICS. Lastly, OT refers to the computing systems used to manage the whole industrial operations. OT is more generic term than SCADA, DCS, and ICS. In order to understand the OT environment, a conceptual model is widely used, namely Purdue Enterprise Reference Architecture, PERA. It is same like OSI model for understanding network layers. Purdue model contains 6 levels wherein level 0 to level 3 considered as OT environment and level 4 to level 5 considered as IT environment. Level 0 contains field devices which collects inputs and send it to level 1 devices which are controllers. Level 2 contains HMIs for managing the controllers. Level 3 contains DCS and SCADA appliances depending upon the network and design of the utility. On other hand, level 4 and level 5 are business and corporate side of the utility. The most critical levels are level 3 and level 4 as they converge IT and OT, which we call IT-OT convergence. Why OT security? Why we are doing this? Industry 4.0 and Industry 5.0 refers to a new phase of industrial revolution that focuses heavily on interconnectivity, automation, machine learning, and real-time data. The increase in connectivity of industrial control system to the internet has opened a new threat vector. Furthermore, last decade has shown prominent attacks on ICS and OT environment. Usage of commercial off-the-shelf products, COTS, can be obtained and operated at a lower cost as compared to custom-built software. But software security is a serious risk of using COTS product and softwares. Integration of IoT in OT, which we call IIoT. IoT sensors and actuators are having direct connectivity to the cloud via fog and edge computing layers, therefore provides a gateway for an attacker. Enterprise and process control network connectivity. IT-related attacks can easily pivot into process control network. All the IT attack surface becomes OT attack surface then. Impact of OT security breach is always greater than IT security, since the factors of human, environmental, and safety issues are there. Apart from these common factors, there are other factors which makes these systems vulnerable. For instance, outdated equipments, proprietary protocols, outdated asset inventory, there is no configuration tracking, and business side is having no visibility into OT networks. Common myths. Operational technology and its cybersecurity is in the early stages and gradually evolving. However, there are some typical misconceptions between the people working in industrial automation when it comes to cybersecurity. In this slide, we will discuss about those common misconceptions and myths. We will start with the first one, which is we have a firewall and IDS deployed, but they don't care about the rules and signatures. Second is we are air gapped. If we consider the fact that, okay, if you are air gapped, the traffic from the business network will not go into the OT network. But what if someone inside the OT network plug the USB? Will you able to detect that? Third one, we have SIS and safety devices deployed. Why hacker will target us? But ideally, they don't understand it's a critical infrastructure that impacts the nation's economy. Then we are not connected to business network. If you are not connected to the business network, they think, okay, we are secure. And there's a very common misconception which lies in the fact they think IT security is more important than OT security. But ideally, it should be noted that OT security is always critical than IT security, since human safety and environmental factors are involved. OT monitoring solutions, most of the times referred as OT SOC. Generally, these solutions provide two modes of monitoring, namely passive and active mode of monitoring. In passive mode, it captures all the PCAPs, analyzes it, and gives all the information to the server. This information includes vulnerabilities, assets information, firmware version, etc. In active mode, a proper scan is performed as per the policy defined, wherein we actually send the packet to the remote host in order to find useful information. This solution provides many benefits like 24/7 continuous monitoring of OT assets. Other benefits includes vulnerability management and of course the coverage and the information of the OT assets at the enterprise level. Generally, this solution get easily integrated to the enterprise SIM and SOAR for efficient automation and incident response. There are many vendors in the market. Some of them are shown in this slide. In this slide, we will discuss about the deployment of OT monitoring solution. We have taken a reference of Nozomi solution where deployment is presented with mapped Purdue levels. Typically, span or mirror port is configured at layer 2 switches and sensors are deployed. These sensors collect information based on configuration and send it to layer 3 servers, which is a management console of OT monitoring solution. These multiple plant-wise management console, on other hand, is connected to the centralized management console of OT monitoring solution at layer 4. The integration of OT monitoring solution and enterprise SIEM occurs at layer 4 and layer 5, depending upon the architecture. This is a common deployment technique used in majority of the OT monitoring solution available in the market. Challenges in OT monitoring solution deployment. There are many associated challenges with the deployment of OT monitoring solutions. When we deploy these solutions, we have to construct a parallel network which integrates OT SOC to IT environment. This becomes overhead and additional thing for experts working at plant site. Other reasons include maintenance and responsibilities. By integrating OT SOC to enterprise SIEM, we are increasing the connectivity of layer 3 and layer 4 as per Purdue model. If not secured properly, it becomes a threat vector. As we are deploying the product of third party to our environment, There is always a risk of information disclosure. As SOC as a service is rapidly increasing, third party are having the access to the OT SOC. We can never trust outsiders. Identity and access management, privileged identity management, and privileged access management for OT monitoring solutions should be implemented properly. Remote access for troubleshooting, etc., sometimes allow an attacker to gain access remotely to OT assets. Keeping aside the above-mentioned points, management of integrated IT/OT SOC is full of difficulties. OT teams doesn't know what to do with the incidents, while IT team doesn't know how to close the incidents and provide in-depth playbooks to the OT team. There is a gap between IT and OT team when it comes to cybersecurity. OT team focuses on safety and IT team focuses on security. What is blockchain? Blockchain is digital decentralized technology which maintains a record of all transactions over a peer-to-peer network. It reduces vulnerability and increases transparency as every node in blockchain maintains its record of transactions. After every transaction, a record is broadcasted to all the peers so that they can update their record. Everyone is having information about each other. It is distributed and not controlled by a single entity. The name blockchain is termed because each group of transaction on a blockchain is referred to as block, and each block is combined in order to form a chain. In simple words, we can say it is a linked list kind of data structure except of pointers. As in blockchain, we have hash for the node connectivity. The first node or block contains the configuration for whole database. It is known as Genesis block. Therefore, configuration of Genesis block should be done securely with good ciphers and key length. So what are the blockchain concepts? The concept of blockchain are many, but here we are only focusing on the concepts that we have used in this OT monitoring solution. Some of them are the concept of decentralization. If you are creating a blockchain environment, you are creating a decentralized environment, which in fact give you a benefit like there will be no single point of failure and the benefit of high availability. Then there is a concept of transparency. If there is a transparency, then again there will be no man in the middle attack. Third is immutability. The database cannot be tampered and deleted once created. Blockchain use cases. Blockchain is considered as one of the notable revolution in a field of financial technology, but blockchain applicability go far beyond cryptocurrency and Bitcoin. There are numerous use cases of blockchain. We have rounded up some of the top use cases in the field of cybersecurity. In this slide, we will delve into the list of blockchain use cases, and we will start with Bitcoin and decentralized currency. We all know this. Then governance. In governance, blockchain is used for audit tracking, report tracking, and fraud detection. In identity and access management, blockchain is widely used. In asset tracking, in data management, in IoT, it provides privacy, which is a key issue in IoT. It is applicable in digital forensics for robust and tamper-proof artifact collections. It is applicable on cyber threat intelligence for secure collection and sharing of TI feeds. And lastly, decentralized applications. Let's talk about applicability of blockchain in OT monitoring and what are the key benefits blockchain can provide us. Some of them are decentralized network and application, via which we can give secure access to third-party vendors, integrators, relevant IT and OT stakeholders. We are having the benefit of immutable database. There is no tampering, there is a consensus, there is a privacy. Blockchain can act as an intermediate network between IT and OT, via which you can bifurcate and decrease the connectivity between the IT and OT, which is there for the monitoring purpose. In fact, blockchain is applicable on the SCADA monitoring also. We can make a separate SCADA monitoring solution which is based on blockchain. So that will bifurcate the connectivity between the IT and OT, and it will create a separate network altogether. So what is our proposed work? As you can see in the figure, we have eradicated the connectivity of IT and OT environment precisely level 3 to level 4 and 5, which is a business network. Moreover, for monitoring purpose, a separate decentralized blockchain-based network is created and a secure access is given to IT and OT respectively. We have used Hyperledger Fabric in this solution, though we can implement this on other platforms like Ethereum, Quorum. I will not say Coda and Ripple since it is more suitable for fintech applications. Let's talk about the benefits now. First and foremost is again, it is creating a decentralized OT SOC. Second is access control, accountability, and authorization. We are giving a secure access from both IT and OT respectively. Third, it is creating a robust cyber threat intelligence database. Although you can make your own blockchain-based cyber threat sharing platform as well, if you are using the concept of blockchain. Again, secure connectivity to enterprise and business networks, robust network forensics, since database is immutable, in case in future if some incident happen, you are having a proper logs, which is immutable, which can't be deleted and tampered. When it comes to challenges, we would say all challenges associated with the blockchain technology is applicable on BBOTMS, which is our proposed work. For instance, scalability, processing, security, etc. But this concept and approach assumes that we have implemented blockchain and configuration of Genesis block in a secure manner. Why not hash graph? Many of the professionals, researchers, peers must be thinking about hash graphs and why we are not using hash graph in OT security monitoring. It has a significant benefits over blockchain, like it is faster than blockchain, it is equal level field, it is provable and verifiable, it is secure by Byzantine, it is cheap and 100% efficient. The answer to that question is yes, we can use hash graph as well, but it has some limitation like patented technology. It is not easily available. And the majority of the problem arises when you integrate hash graph with the existing solution that you have. So these are some of the limitations due to which we are not using hash graph for this. But yes, if you have a paid subscription for the hash graph, you can implement this concept using hash graph as well. All right. Thank you for attending this session. I hope you find it interesting and useful. If you have any comments, questions, or just want to discuss, do not hesitate to ask. Thanks again.